Hello friends, welcome to my YouTube channel Manoj Networker. So today we'll see what is an access point in this video. So basically an access point or AP in short is a physical device that allow wireless devices to connect over a network like the internet. So it acts as a bridge between the devices and the network, providing a wireless connection. So access point is an well defined term. So even in our home routers and home devices also we can see one modem. So that modem will wirelessly connect all our laptops, all our desktops. In the same way, in real time also we have the access points, but they are more modernized version. Like they can provide some sort of security, they can distinguish the VLAN traffic. Those things can be done in real time. So if you see this picture, we have the Ethernet layer 2 switch where all our computers and servers are connected. And on the other hand, we have two access points connected, and this access point will connect to the switch and they will get the power and the data. So this is called as a PoE link, power over Ethernet. And if you see, all the devices are connected wirelessly to the access point. So the data will go to the switch, and from switch it will go to the router, and from router so they will go to the internet. So this is how the access point will be working. So AP creates wireless local area networks, also called as WLANs, for greater mobility, enabling the need for wide connection. So they find wide applications in homes, business, school, and public spaces with diverse design to suit various needs. So APs can be used in our homes and for the businesses. So as I said, for example of our home Wi-Fi, so that will not provide that much security, but all our devices can be connected to our home router or home modem, and we can access the internet. Whereas the business users will use commercial access points that will connect large number of people and IoT devices to the internet. So they are designed to scale and provide the network security. And this is an wired LAN and this is an wireless LAN. But both are sitting within the LAN. The basic difference between wired LAN and wireless LAN means the end users will connect to the network without any connection. So all these computers has a wireless connection and they are going and reaching to the internet. So basically, how does a wireless access point work means? So access point establish a direct link with the network switch or router via Ethernet or database data cables, facilitating WAN connectivity. So this is very important, guys. So the connection from access point to the Ethernet switch is not a wireless. That is a wired connection. But the connection from access point to the computers or to the laptops is a wireless connection. So that's how the wireless access point network will be established in any given LAN topology. And it can operate in 2.4 gigahertz and 5 gigahertz frequencies, enabling wireless devices to establish connections. So this effectively broadens the reach of internet access, surpassing the confidence of a single router. So the access point will help connecting more users and gaining more strength, and they can reach to the internet, and you no need to buy more number of switches and routers to finish this task. So this is very important. What is 2.4 gigahertz and 5 gigahertz for the interviews, and what are all the limitations? So basically we have seen wavelengths in our old school days. So just as a pictorial representation, I am just showing the wavelength. So this is how the 2.4 gigahertz will be, and the bottom one will be 5 gigahertz. So these are the wavelengths. So basically if you see these two are the frequencies in the Wi-Fi that we will be using. So 2.4 gigahertz range has a longer range than the 5 gigahertz bandwidth. So a 2.4 gigahertz connection travel further at lower speeds. That means 2.4 gigahertz if you are using, it can cover more space or more area, but at lower speeds. Whereas 5 gigahertz frequencies provide faster speeds but for the shorter area. So your choice of using 2.4 gigahertz or 5 gigahertz is completely depends on how you use and how your Wi-Fi connection will be available to that given area. So if you see, the major differences between 2.4 and 5 gigahertz will be 5 gigahertz will support only smaller coverage area, but it can provide higher data rates. Whereas on the other hand, 2.4 gigahertz can travel longer distances, can cover pretty much big area, but lower data rates. So I have even added one more diagram, so to make it a simplifier. So if you see, if I am using 2.4 gigahertz in this computer, the person sitting in this farmhouse also in this laptop, the 2.4 gigahertz they can use. Whereas if you are using 5 gigahertz, that will be limited to within this house premises. So where to use 2.4 and where to use 5 means that's completely depends on your scale and comfortability of your LAN infrastructure. There is no such rule like only you need to use 2.4 and only you need to use 5 gigahertz. So depends on the things we can change whatever is needed. So 5 gigahertz will give you more signal strength and faster speed over a shorter range compared to 2.4 gigahertz. I hope the differences are clear now. And advantages of a network access point. So increased user availability. Yes, of course, because it can connect 50 users or it can connect 100 users also wirelessly. So they all can support our businesses and ensuring the uptime of our business. And extended signal coverage. So wherever if you have some problem in putting some switches and all, or if you consider any warehouses and all, so it will be impossible to go and penetrate these kind of LAN cables and all. So wherever that is having this kind of problems, so we can put one access point so that it can cover up to 100 meter 300 meters also wireless connections, so that with a wireless access point in place, users can seamlessly navigate and roam across this extended network, providing a more versatile and efficient connectivity experience. So basically access points will provide extended signal coverage and adaptable network configurations. So this configuration of this access point is also so simple that you don't need any rocket science to do this. So within a fraction of seconds with the help of wireless access points, so we can configure the network configurations and we can make one access point up and running. And moving further, vendors. So vendors are very important. So who will manufacture the devices? I have named out a few. So Aruba is one of the major vendor, Cisco followed by and Juniper. So all these people, they will manufacture the access points. And types of access points, again important for your basic interview questions. What is an internal access point and what is an external access points? So the picture what you are seeing is attached to a ceiling on the top of the wall for a company, and this is an external access point. So how I am telling this is an external antenna access point means, if you see, this is an access point but the antennas came out from that access point. So this is how an external access point will be looking like. So if I scroll further, you see two access points. So these are from Cisco. The hardware version is 3800i. I is nothing but internal access point. E is nothing but external access point or AP. So the main difference between them is, so internal access point, it has a omnidirectional coverage pattern. So basically the access points will be mounted on the ceiling with most of the radiation propagating downwards. So the internal access point will be useful for offices, schools, hotels, etc., where there is no major changes are needed. So then you can use your internal access points. But for external access points, it can shape the coverage based on your requirements. So to meet the most of the challenging design requirements nowadays, so if you are particularly wanted to give your Wi-Fi outside of the your office premises or outside of your school, then we need to go for external access points. So with an external antenna, one can mount the AP and the antennas separately, so that AP can accommodate the harsh environment conditions also. So this access point has the capability to meet the harsh environmental conditions also. and particularly these access points will be using in the warehouses. Like let's say you consider any Flipkart warehouse or Amazon warehouse, where we'll have big rooms that will go beyond 25 feet to up to 80 feet. Okay, and we will normally see this kind of warehouses. So if you have this kind of patterns and if you use internal access point, you will not be able to meet the requirements, because internal access points are omnidirectional and it can perform well up to 25 feet. And also in the warehouses you will see high metal racks, inventory and volume of product, and all can impact your signal strength. So it's better to use these external access points in the warehouses. Again, in addition, other dynamic challenges to consider, such as heavy machinery and moving warehouse vehicles, can also impact coverage and network performance. So you need to think about all these things. So before buying any access point, and placing of access point in any place is also important. So we have a tool called Ekahau in the real time. We need to do the site survey. So it's not as simple as it is like, we are buying the access point and we are installing somewhere in the office. No, it's not like that. So we need to do some sort of site survey with the help of Ekahau tool. So I'll talk in my upcoming sessions how to do the site survey and all. So we need to see if I put where many users will be useful for this AP. So I need to find out that place and I need to install these access points. So moving further, introduction to WLC. So WLC plays a vital role in our networking team. So WLC stands for wireless LAN controller. So basically wireless LAN controller, the main job of this WLC is to manage the wireless access points and allows device to connect over a network. Since we have so many access points in the real time, so consider, just for example, you have 2 access points here and you have the wireless controller. So wireless controller again is a physical device. So this is how it will be looking like. So me as a network admin, I have the access to this wireless LAN controller. I can log into this WLC and I can manage both of these access points. So network performance. So WLCs can help optimize the network performance and limit the downtime. So sitting from this WLC, you can manage both of them. So central point of contact, you can say. So central control. From this WLC, maybe you can manage 100 access points also. So WLC provide central control over network elements, so making it easier to monitor the individual components, because the access points will be mounted somewhere on the top of the ceiling. So I'll not be able to go there to see the access point how it is working. But if they are connected to this WLC, sitting from my home, sitting from remote, I can access this WLC. Through this WLC, I can see the statistics of this 10.51 IP and I can see the statistics of 10.52 IP, like how many users are connected, how many SSIDs are broadcasting, which building the EP is in, how many users are connected, which frequency it is using, 2.4 or 5 gigahertz. Okay, so all those kind of things we can do from WLC. And yeah, that's all for this video. So in the upcoming sessions I'll be discussing more about how the relationship between WLC and AP, what is a CAPWAP tunnels, how the CAPWAP tunnels will be established, and how access point will identify the WLC. So those things will cover in upcoming sessions. So thanks for watching. That's all for this video.